So the main question in here is, can revised simplex method be used to solve linear programming problems when some constraints have greater than or equal sign, or actually equal sign? They will work the same way. The answer is yes, but we do need to make some adjustments. Let's use an example to demonstrate the procedure. In this example, a maximization problem is used with 3 variables and 4 constraints. Because of the presence of that greater than or equal sign in one of the constraints need to be solved with one of the approaches, such as big M or two-phase method. Those constraints in standard form. Now if we want to, for example, use big M method that I'm going to be using in this example, we need to add artificial variable to the first constraint, R1, and then penalize the objective function by subtracting minus mr1 from it, where m is a very large positive number. This is a standard approach in big M method. Now let's look at what adjustments are needed. The first adjustment that will take place is introduction of S1 as one of the main. So a matrix which usually has coefficients of main variables x1, x2, x3 in this case will now include the coefficient of S1 as well, and appropriately coefficient of S1 in the objective function, which is of course 0, will be added to the C vector. Another major adjustment that needs to be done is that right now the artificial variable will have the coefficient of minus m in the CB. Remember, R1 is one of our basic variables, so the coefficient of R1 in the CB needs to be considered. Those are the adjustments that we need to make. The rest of the procedure is the same. Now let's demonstrate the procedure, and I will be using Maple software for calculations involving matrix operation. Here I have created a Maple sheet. We have done the same thing in the previous video, so I'm not going to spend a lot of time discussing some of these steps. So you can take a look at the procedure. That's just the main problem that we are introducing again in here for the purpose of reference. The main commands that we used before are these commands. We start with the restart, so we will clear any memory that might be involved, and we will be using the linear algebra library. We are introducing the A matrix. These are the coefficient of the x1, x2, and x3. However, I have added the coefficient of s1 to A also. We will be introducing P1, P2, P3, and P4. This is the coefficient of S1 again. We are going to introduce the matrix B, the right hand side matrix. We are going to introduce the C vector, and notice that the coefficient of S1 is also added to the C. Now we are introducing our first basis. This basis includes R1, our artificial variable, S2, S3, and S4. We are going to do the calculation for B. Our B will be the identity matrix. The CB in here will now have the coefficient of R1. As we discussed, this is a -1 coefficient of R1. So we are going to perform the operations. B inverse, CBB inverse, CBB inverse A minus C, these two which will identify for us the optimality conditions of the problem to identify the entering variable. For R1 in the CBB inverse, notice that in the tableau structure this needs to be 0, and that is the only contradiction that you are getting in this procedure. But in any case, this value minus 4m minus 5 minus 4m minus 5 is the most negative number, so I will be doing the calculation for the right hand side, B inverse B, and because the entering variable is going to be this variable, which is x1 and x2, this is the x2 column, I will be calculating the B inverse P2. So I will calculate those values for 1 minus 3 and 2, and based on these values I'm going to calculate the mean ratio. I will be having 12 over 4, 20 over 1. Because this is negative number, I'm not going to do the calculation. That remains blank. And then 18 over 2. 12 over 4, 20 over 1, and 18 over 2. The minimum is 312 over 4, and that's corresponding to R1. Therefore, x2 enters the basis, and R1 will leave the basis. At this point in time, we can do the calculation for z if we want, which would tell us it would be negative 12m. Of course, it's not needed at this stage, but that is what we will do. Now we are going to save this document under a name, anything that you want to name it. And I will use a copy of this same document. And then I will go back all the way to the top of this document. A is the same. And I'll start again. I'll start from the restart and with linear algebra. A, P1, P2, P3, P4, they are all the same. B is the same. And C is the same. These are fixed values that will be kept there. However, I'm going to change the XB. In this case, x2 is going to enter and replace R1. So let's look at the document and see how it looks. And here we go. So let's start from here, go through the process, and let's do the calculations. And the new XB in which X2 is replaced. Now I'm going to write the new B vector, in which the column of X2 has replaced the column of R1. Appropriately, I'm going to change the CB, and this is going to replace that value. Now I'm going to do the calculations for B inverse, CBB inverse, and CBB inverse A minus C. These two are my optimality conditions, and as you notice, I have negative value in here and negative value in here. These are the two negative values. I'm selecting the minus 7/4, which is the most negative number, and this is associated with x3. This is x1, x2, and x3. So it is associated with x3. So x3 is my entering variable. I will be calculating the right hand side, and I will be calculating the column for x3, which is b inverse p3, and these are the values. Now I'm going to use the mean ratio. I will find the ratio of 3 over 1 quarter, 17 over 7 quarter, 33 over 11 quarter, and 12 over 1 half. These values are written in here, and the smallest value is 68 over 7, which corresponds to S2. So this is the leaving variable. S2 is the leaving variable and will be replaced by X3. And that is what is going to happen. Again, the same thing. I'm going to save this that has all my calculations, and I will be using a copy of this document to do my next step. So let me go back and do that. Just remember that X3 is going to replace S2 in this document. Here is the same document, except I'm going to replace the new variable with the old variable. Those are A, B, P1, P2, P3, and P4. Right hand side, C matrix, and now my basis is going to be X2, X3. Remember, this X3 is replacing S2. I will set up the B based on X2 column, X3 column, S3 column, and S4 column. And appropriately, I'm going to create the CB with the coefficient of x2 and with the coefficient of x3 at the first and second place. Now I will be doing the regular calculation. I will find the B inverse, CBB inverse, and CBB inverse A minus C. These two again are my optimality condition, and as I will look in here, I notice that there is another negative number in here. So associated variable with this one, which happens to be S1, is going to enter the basis. To identify which one is leaving, I'm going to calculate the right hand side values, and I will be calculating the column associated with S1 for this iteration, which is B inverse P4. Remember, S1 is now the P4 column, and these are the values. Again, these two are negative, so I'm not going to do the calculation for the ratio, and this one is going to be 68 over 7 over 1 over 7, and 57th over 3/7. From these two, the mean ratio is 50 over 3, which corresponds to S2. Okay, this is what we have, and we're going to go through the same process, defining A's and all the fixed values. Remember, the B matrix and C matrix, they all are fixed values. From here, my XB is going to be changing. It's the previous one, except that the last one is changed with S1. So accordingly, I'm going to create the B matrix based on these variables which are in the basis. These are the coefficients of the same variable in the main problem, and I'm going to create the new CB. In this case, because S1, which its coefficient was 0, changed with S4, which its coefficient was 0, this CB remains as the one in previous problem. So I'm going to do the calculation, B inverse B, CBB inverse, and CBB inverse A minus C. These are my optimality conditions, and as I look at them, there is a negative number in here, and that number happens to be under the x1 column, x1, x2, x3, and s1. So this is x1 column, so x1 is my entering variable. To do the calculation to identify which variable needs to leave the basis, I will be calculating B inverse P1 because x1 is entering variable. And in this case, we see that the right hand side value B inverse B for the new iteration of these values, and B inverse P1 of these values. There's only one positive value in this case, so that will be the leaving variable. And remember, according to our XB, this was X2, this was X3, this was S3, and this was S1. So we do the calculation, and X3 leaves the basis, and what enters? X1. So X1 is going to replace X3 in this in the new iteration. Again, if you want, we can do the calculation for Z, but it is not needed at this stage because we are still not at the optimal solution. Again, we are going to save this sheet, and we will be using a copy of this sheet to create the new basis. For our iteration, we will be using the same sheet. Okay, here we go, and this is the new sheet, and again the same type of needed calculations. It's just a simple matter of pressing the enter key and it will do the calculation for these stages until we get to XB, and in this case I have to change that. Now my new basis is X2, X1, S3, and S1. Accordingly, I will set up the B based on these values, and similarly the CB based on these values. Now the coefficient of x1, the coefficient of x1 in here, which is 1 in the objective function, has replaced the coefficient of x3 that I had in here. Again, the same type of calculations, B inverse, CBB inverse, CBB inverse A minus C, and these are my optimality condition, and as I look at them, there is no negative number in here, and thus this is the optimal solution. As I have reached the optimal solution, I don't need to do any more min ratio calculation. I will be calculating the main numbers that I am interested in. B inverse, B the solutions, and the z-value. So these are my optimal solution with this optimal xp. We can check the results that we have gotten from this process using another software such as Lindo, and the numbers will match. That's it.